Hello, my name is William Zhao. This is our Project 2 in Engineering 6 where we manipulate sound using MATLAB. I was in charge of the chopping.
Hello, I'm Stephanie Size, and I was in charge of loading the samples and providing playback. And in addition, creating the GUI and connecting the commits.
I'm Kimia. I was in charge of creating the sound effects that were later implemented onto the GUI and creating the panel, which gives the user the option of creating a pure tone with a given frequency, amplitude, and wave shape.
Hi, this here is our diagram for our program's functionality. In our GUI we have 9 different buttons, but here we are just displaying how one works. So first, the user inputs a file, and then they get to choose between mono or stereo playback when they press this push button. Then from here, it sends the information through handles to the playback push button, and this reads what file is being played, and then it sends that information to the static button, which displays which file is being played. And then from there, you can choose between what sample you'd like to edit through a drop-down menu, and this here contains the data for the playback sample. And then from there, you can go, the sequence of events doesn't matter. It goes, you can choose between first editing the special effects or the chopping. And if you go through this route, you can choose from various different special effects, and that is going to be saved into an array where when you do the chopping, you will choose the starting and ending time of it, and that will save into the chop sample, and then that will be, both of these will be sent to a push button where you can update it, and this special effect array will index the chopping, and so then you will, when you push it, it will send it back to the original push button, and it will update it with special effects and chopping. The way our program is set up, the user is able to load 9 different WAV files into the program for playback. When the user clicks the load button, they are able to directly choose the WAV file from their MATLAB documents. Once the user loads their file, a pop-up box appears where they can choose between mono or stereo playback. And as we can see here, if they choose stereo, it plays on both channels, whereas if it's mono, it only plays one side. And once the user uploads the file they want, they are able to use the playback function by simply pressing on it, and as they press it, it shows appear in the static box what WAV file is being read.
Applying an effect to a given sound file involves altering the sound arrays and sampling frequencies. Our first sound effect is shown right here, which is reversing the sound, which can be done simply through flipping the sound array. Here, changing the speed of the song requires simply altering the sampling frequency by a certain factor. Decreasing the sampling frequency will slow down the music, while increasing it will speed up the music. Here, we also created effects to soften either the high or treble or low bass components of the given samples. Here, to create an echo in the sound, we had to create a delay amount, which is a certain number divided by the sampling rate. The sampling rate is usually 44,100 samples per second for a CD. Then the sample from a previous time is added to the sound sample, which when using stereo creates an echo from left to right and right to left. Here, in order to minimize the volume of the vocals, we subtracted the sound coming from one channel from the sound coming from the other. This works because the volume of the vocals is fairly equal between the two channels, while the volume of the instruments is uneven.
The goal for chopping is to be able to edit and choose specific sections of a wave or sound sample file. In order to do this, we must understand the relationship between the size of the sound file and time. The length of time in the sound file is related to the size of the file by multiplying the time by a sample rate, which is usually 44,100 Hz. The program we created starts with the user entering a specific start and stop time, located here and here. The times in seconds the user has entered is then implemented into our program and is multiplied by the sample rate. This sets the start and stop times to a specific row in the array of the wave file or sound sample. Finally, when we use the sound function to play the wave file, we use the start and end points we calculated to specify a certain part of the wave file array to produce the sound from a specific section of the whole wave file array.
A pure tone consists of a given frequency of sound played for a certain amount of time with a given amplitude and sine wave shape. To create a tone in our GUI, we implemented 3 text boxes, allowing the user to choose any sound frequency within the audible range, which changes the pitch of the sound, an amplitude, which changes the volume of the sound, and we provided 3 choices of wave shapes, including a sine wave, square wave, or triangular wave. The different wave shapes provide different tones for the sound. A sine wave produces a sound lower than the other shapes because it is playing only the fundamental frequency. A triangular wave sounds somewhat higher and louder than the sound wave, since it uses only the odd harmonics above the fundamental. A square wave is more similar to the triangular wave, since still only the odd harmonics are present. However, it sounds even louder than the triangular wave. In the code, handles are used to access and share the user-assigned variables. We used a set sampling frequency of 44,100 samples per second with an array of time to create the tone. The code is generated so that after the user selects a wave shape, the given frequency will be used along with the set amplitude to play the sound after the button is pushed.
To illustrate how the GUI works, I'm going to show you some of its functionalities. So as you can see here, we have a panel named Sampling Grid where you can store 9 different WAV files. But for this demonstration, I'm only going to upload 1 WAV file just to show you how it works. So here, it opens up directly to the documents of MATLAB where you can choose whatever WAV files you have. So I'm going to choose Hootie. So open, and then we get the choice of stereo or mono playback. And now, if I press the corresponding playback button, it should play back the WAV file, and in the static text, it will show you what WAV file is playing. And in addition, we have a plot that demonstrates the audio file. And so next, we can choose what sample we'd like to edit, but since we have provided information to playback button 1, we're going to choose sample 1. And then we can choose from various different special effects. I'm going to choose reverse. And then we can choose how much we want to chop the song. So I'm going to have start time of 1 second to 5. And then right here, it executes the chop. And now if you click the update sample, it will have the reverse and the chopping. So now here, it has updated the original sample, so we should hear it play in reverse in 5 seconds.
Here we can create a tone with a given frequency, wave shape, and amplitude. So first I will give the GUI a frequency of 440 Hz, which should be equivalent to a middle A on the piano. And I will choose the sine wave function and an amplitude of 2. Now I'll try a frequency of 1000 Hz, which should be relatively higher in pitch. We can also change the shape of the wave to a square wave, which should sound somewhat louder than it was previously. Thank you for giving us the opportunity to work on this project and learn more about MATLAB. I'm sure we're going to use it in a lot of classes later on at UCD, and this was a very helpful project.
After taking Engineering 6, I feel feel more comfortable using MATLAB. And even though we barely scratched the surface, there are way more functions, and I can't wait to explore the different uses of MATLAB and become more of an expert with its functionalities, since it's, I think, vital for our future.
This concludes our presentation. We hope you learned a lot, and we definitely recommend you learning more MATLAB functions for future classes and jobs in the future.